Example 3 says graph A, B, and C, which it's already done for you right there. And it says determine if triangle ABC is acute, obtuse, or right. This looks like an obtuse triangle, but we need proof to draw the correct conclusion. So it says use the distance formula to find the length of each side. So that's the first thing that we need to do is find the length of each side using the distance formula. So I know that A is 4, -1, B is 3, 8, and C is 9, 6. So what we're going to do is we're going to use the distance formula. So every time we use it, we write it down. Distance is equal to the square root of x1 minus x1 minus x2 squared plus y1 minus y2 squared. That's the square root of all of that. So let's go for the distance between A and B first. So it's the square root of, it's going to be -4 minus 3 squared plus 1 minus 8 squared. So then 4 minus 3, that's going to be -7 squared plus 1 minus 8 is -7 squared. I put that on the wrong side. Needs to go on the outside is -7 squared. So the square root of -7 squared is 49, plus the square root of -7 squared is 49. So then I have 49 and 49 gives me 90, the square root of 98. And then I have to take out any perfect squares in here. And the perfect square in 98 is 49 times 2. And the square root of 49 is 7. And that leaves me with the square root of 2. So the length of segment AB is 7 square root of 2. So I'm just going to write that over here. 7 square root of 2, that's AB. So then let's take a look at BC. So again, I'm going to write out the distance formula. Distance is equal to the square root of x1 minus x2 squared. That doesn't look like a squared there. There we go. Plus, now I'm putting x again, y1 minus y2 squared. So here, BC is equal to the square root of 3 minus 9 squared plus 8 minus 6 squared. So 3 minus 9 is -6 squared plus 8 minus 6 is 2 squared. So that's going to give me -6 squared is 36 plus square root of 2 squared is 4. So that gives me the square root of 40. So then the question is there any perfect squares in 40? And there is, because I have 4 times 10. So then the length of BC is going to be equal to 2 square root, I'm going to put 5. 2 square root of 10 is the length of BC. So I'm just going to put 2 square root of 10 over here for BC. So let's take a look at the last one here. That is AC. Okay. So I have distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, I know that it gets tedious. You're probably going, why am I writing this formula out 3 times? Well, the rule is every time you use a formula, you have to write it down. This way, it forces you to memorize that formula so that when you're taking your ACT or anything else, it comes back much quicker and you will remember that. So on this one, AC is the square root of 9 minus 4 squared plus 6 minus, I have a negative 1 squared. So 9 minus 4 is 5 squared plus, now this right here, 6 minus negative 1, that's going to be 6 plus 1, which is 7 squared. Okay? How do I get 7? Yeah, 6 minus 1, which is going to be 7 squared. So when I do this, I made a mistake. This is a negative 4 here. I didn't make it on the AB, but I was like looking at it going, something doesn't look quite right. I'm going to cut back up to here because this is going to be a negative 4, okay? Because it's a negative 4, negative 1. Now we're on the right track. So negative 4, 9 minus a negative 4 is going to be a negative 13 squared plus, this will be 7 squared. So I'm going to get a 169. Why did I get 7 again? That's a positive. See, look right here. I wrote it backwards. It's a positive 1. I got to pay attention here. It's a positive 1, a negative 4, positive 1. So, sorry about this. So then this is going to be, I don't know why, this is going to be minus 1. So this is going to be 5 squared. So then I'm going to get the square root of 169 plus 25. So this is going to be equal to 169 plus 25 is 194. And there is no perfect square in 194. So then I have the square root of 194. The square root of 194 is my longest one. Now we're going to use the Pythagorean theorem and look at the square of my legs versus the square of my longest side to see if it's a right, obtuse, or acute triangle here. So I'm going to say a squared plus b squared is equal to c squared. So let's be 7 square root of 2 squared plus b is 2 square root of 10 squared is equal to the square root of 194 squared. Okay? So then 7 squared is 49, and then the square root of 2 times the square root of 2 is equal to the square root of 4, which is 2. So anytime you take a square root and you square it, your answer is always going to be what is underneath there, that's called the radicand. So then this is going to be 49 times 2 plus 2 squared is 4. That'll be times 10 is equal to 194. So now 49 times 2 is going to be 98 plus I'll have 40. I forgot my squares here. I already squared them. What am I talking about? It's going to be 98 plus 40 is equal to 194. And 98 and 40 is 138. And that is less than 194. So triangle ABC is obtuse because the square of the longest side is bigger than the square of the legs.